In this video, we want to start looking at improper integrals of type 2. Now for this, in type 1, just as a reminder, type 1 is when we have bounds with infinity or negative infinity. Here, we're going to deal with bounds that are vertical asymptotes. So, if f is continuous on some interval a to b, we include a on one side, and it's an open interval on the side with b in it. So we're going to have our asymptote at b here. If f is continuous on this interval and is discontinuous, at b, then the integral from a to b of f of x dx will equal the limit, as now our problem bound is b. That's where we're going to have a vertical asymptote. So then limit as t approaches b, but from the left, right? Because we're inside this interval for our function. So we're approaching b from the left. And we're going to replace that problem bound with t and f of x dx. So this will be true provided that limit on the right exists. Okay, and so that is our way to solve these type 2 integrals, improper integrals. We can define something similar if the problem bound is on the left. So if the asymptote happens at a, except t will replace a in the lower limit of integration, and we would have t approaches a from the positive side because we'd want to be on the interior of this interval. Now, how do we actually solve these? Well, we just do this limit, and we've got a lot of practice with that from our previous problems. It's just the only difference now is that t isn't approaching infinity or negative infinity, it's approaching some finite value from one side. So let's go ahead and do an example here. And this example 1, how about we do the integral from 0 to 5 of dx over the cube root of 5 minus x. Okay. And notice that if we plug in 5 here, we do get 0 in the denominator, so we do have some asymptote here. But otherwise, we're fine. If we plug anything between 0 and 5 into this, but not 5, we'll get a positive value inside this cube root. And specifically, we just also don't get a 0 in the denominator. So we're good on the rest of this region. So the first thing we're going to do is we're going to rewrite this as the limit as t goes to 5 from the left, integral from 0 to t, dx all over the cube root of 5 minus x. And now, as before, we solve this using a u substitution. So u is 5 minus x, du is equal to negative dx, or in other words, negative du is equal to dx. If x is 0, then u is 5. If x is t, then u is 5 minus t. All right. And from there, we can replace everything. This is the limit as t approaches 5 on the left. Integral from 5 to 5 minus t, negative dx all over the cube root of u, or in other words, u to the negative 1/3. Add 1 becomes u to the 2/3, then divide by that is 3/2. So we get limit as t goes to 5 from the left of a negative 3/2 u to the 2/3 evaluated from 5 to 5 minus t. This is equal to limit as t goes to 5 on the left of negative 3/2 5 minus t to the 2/3 minus a negative. Or actually, I got this negative 3/2 factored out, so why don't I just do that? Minus u, which is 5 to the 2/3. All right. And from there, limit as t goes to 5 on the left. 2/3, sorry. 5 minus 5, essentially, so that goes to 0. And then we get negative times negative, positive 3/2, 5 to the 2/3. And that is our final answer. So we actually had a finite region in here, or at least area, finite area, even if we had a vertical asymptote at this point. And that will pretty much conclude this example. I'll say one thing here at the end of the video. We must always be careful of making sure that for definite integrals that our function is continuous everywhere inside that interval and at the endpoints. Except now if we have this asymptote or a discontinuity at the endpoints, we can apply this method. And furthermore, if we have a finite number of these holes or asymptotes in the middle, then we can just break the problem up into 2 pieces and do the integral on the left side of this asymptote and do the integral on the right side of the asymptote, and then add up those 2 regions. And if both of those existed, then like in the previous video, we can just add those 2 together to get the whole thing. So we could do something similar here with type 2 if we have an asymptote in the middle. Cool. That is where we will end this video.